Hello. So this today I'm going to continue with where I left the last lecture. In the last lecture, I started talking about aggregation, and we are in the seventh module of the course, and this module is mainly about optimizing, or you can say, query performance enhancing techniques. And as I discussed in the first lecture of the module, aggregation is one of the most effective strategies for improving query performance. And aggregation is all about pre-computing some of the aggregates that are required by queries, and storing them in the data warehouse, right? And using them whenever there is a query. So there are lots of issues with this which we discussed, and we also discussed a very bizarre phenomena related to aggregates, that is sparsity failure. And I explained that in the previous lecture using an example. And I also gave you the design requirements for aggregates in the previous class, and there are certain thumb rules which we should follow. So one of the basic key points that one should remember is that never aggregate along an attribute which does not aggregate, do not aggregate along an attribute which does not aggregate more than 10 lower level records. Say for example, if you are aggregating days to months, so you are aggregating 30 lower level records into the next level, right? So that is okay, that is fine. But anything less than 10 is not recommended, because it can lead to sparsity failure, as we saw in the previous lecture of this module, right? So today I'm going to continue with the aggregation, and I'm going to basically talk about the middleware that I was talking about, that is called as aggregation, that is called as Aggregate Navigator. So I'm going to talk about that. And as I told you in the previous lecture, that the queries that we write or that we submit to the data warehouse, they should not be aware of the aggregates that are there in the system, right? Or they should not know about what aggregates are there, and they should not target those aggregates directly for their queries. So for the end user, only the base level data is available, right? So the most granular data that is available in the database, so all applications should target that, right? So reasons why we say that, so those reasons I'll be discussing today. So let me continue with this. And okay, so I'm going to talk about, as I told you, I'm going to talk about this Aggregate Navigator. So so the question that the question that arises here is that how queries are directed to appropriate aggregates when we say that all the queries should target only the base level data, right? So you understand what is base level data. So again, to see that, you need to go back to the previous lecture of this module and see that base level data, we talked about base level data in the example that we discussed on sparsity failure. So that would give you a very clear idea about what is base level data. So the question is, do end user query tools have to be hard coded to take advantage of aggregates? Now suppose I know that a particular aggregate exists in the database. So should I be hard coding that in my query or in my application that I'm writing, so that I can leverage that directly? Right, it sounds a very good proposition, that I know that this aggregate exists, and I put it directly in my query, and it is used because it is available, and it is used, and my query gets answered very, very quickly, because everything is pre-computed in that. But now just imagine a situation if the DBA changed the aggregates, right? So suppose the aggregate that I'm using in my application or in my query, suppose the DBA decides to drop it for any reason, right? So now when I issue my query, so it will not find that aggregate in the database, and it will say that the object not found, so it will come up with this error, right? So the portfolio of aggregates that exist in a database at any point of time is dynamic, right? So it keeps on changing with time. So today I have a set of aggregates, so tomorrow I may have another set of aggregates which are to be used, or right, because the DBA is responsible for seeing that how many of the aggregates that he has created are being used. So it talks about utilization, because there's a cost associated with each aggregate that I'm storing. There's a cost related to storing the space cost, the space requirements. Then there is maintenance of that view of that aggregate, and there are many other costs associated that I discussed in the first lecture. So the DBA has to take a call. So how do we, so with this background, so how do we overcome this problem? So that is what we will discuss today in this lecture. So for this, there is something called as, as I said, there's an intelligent middleware that is called as Aggregate Navigator, which is used as a solution for this problem. So what is an Aggregate Navigator? So as I said, it's a middleware sitting between user queries and the database management system, or the DBMS, on which you have implemented your data warehouse. With Aggregate Navigator, user applications just speak, or user queries just speak, the base level SQL, right? And what AN does is AN uses what is called as the metadata to transform base level SQL into aggregate aware SQL. So what is happening here is, I'll tell you, this is a query that I submit, right, and it has to be answered using this database, right? So here is the relational database in which I have implemented my data warehouse. So my star schema is residing in this database, right? So I issue a query, which is a query in SQL, okay? And as I said, I have to speak only the base level language, or base level SQL. That is, I am not aware of any aggregates that exist in the database, right? So what do I do? So what this does is, so there is a middleware that is sitting in between, which we call as the Aggregate Navigator. I'll give you the complete architecture in the coming slides, but just to give you an overview, you can see the role of AN here. So this is the Aggregate Navigator. So there is this base level SQL that is issued, right? So aggregate now consults what is called as the metadata. All of you understand metadata, right? So we have a module later on metadata as well. Metadata is basically data about data. So if you are aware of relational databases, right, so you'll know what kind of information we generally keep in the metadata, right? So it keeps information about all users, it keeps information about all tables that have been created, all constraints, all keys, all indexes, right? And of course all aggregates, like as we'll see here. So this Aggregate Navigator takes help of the metadata, and what it does to the base level SQL, it makes it aggregate aware. Okay, so this is what is done, and then the aggregate aware SQL is executed against the database, right? And that's how we make use of, or we exploit the aggregates that are there. So how this Aggregate Navigator works, right? So we'll be discussing that. So there's something called as there's an algorithm called as Aggregate Navigation algorithm, which is used to guide the queries to appropriate aggregates, right? So I'll be discussing that in the next few slides. So this is basically, let me clear the annotations so that, yeah. So I'll remove this part also, so that, yeah. So now, so you see this, and I strongly recommend that all of you please read articles from Kimball, which are available on the Kimball's University, right, on aggregates. So there are 2-3 articles which you should read. So this particular figure has also been taken from one of those articles, right? So I've mentioned here at the bottom. So what happens here is that, so let me change the color of this pen because there's a lot of red already here. Yeah. Okay. So what happens is, this is the end user PC through which my client application is running, right? So I'm issuing a base level SQL, right? And it goes to the aggregate navigator here, right? So this is my aggregate navigator, okay? And it goes to the metadata. So this is my metadata, as you can see here, okay? So it consults the metadata and then makes the query aggregate aware, right? Okay. And how it does that? So suppose you issue a query, SQL query, so it will see what kind of fields are being used in the where clause and in the join conditions, and what kind of aggregates are being used. So it kind of parses that query and then tries to see that if there is an aggregate which can help in answering that query, right? So that's what it does. And then this aggregate aware SQL is subjected to the DBMS, and this DBMS goes to the database, right, and and returns the answer to the user, right? So, and there is this, and by doing this, it has kind of optimized the query. So this is what happens with aggregate navigator. And once I tell you that the aggregate navigation algorithm, so you will understand it much better. So this is the aggregate navigation algorithm, right? So what I do is, so there'll be lots of aggregates that I would have created, okay? So and these aggregates would have a kind of a size, right? So each aggregate will have a size in terms of number of records it has. So what I do is I rank order all aggregate fact tables from the smallest to the largest. So what I'll do is, this is how I'm saying that these are different aggregated, right? And bigger the box, that means more records in it, right? So this is an increasing order in size, and I'll use a different color to illustrate the base level. And base level would be the biggest, right? Because more detailed data is there. So what I do is, when a query comes, right? So when a query comes, right? When a query enters the system, so I would have rank ordered all these aggregates that exist, right, for the fact table. Now when this query comes, so what I'll do is I'll go to the first smallest fact table, aggregated fact table, and then see whether this can answer my query, and it's associated. So each of these fact tables, aggregated fact tables, would be associated, would have an associated set of dimension tables, right? So I'll see if what are the associated dimension tables with this fact table, and whether my query can be answered using the dimension tables, the attributes that are present in the dimension tables, and the aggregation that is done in the fact table. So if this aggregated fact table and its associated dimensions are able to answer the query, then I'm done. If not, then what I do? Then I move to the next smallest aggregate, and then again I try the same thing, and I keep doing this, right? And ultimately what will happen is that I'll reach the base level SQL, right, or the base level fact table. So this is the base level fact table. That is the the one that is originally present in the data warehouse. So by doing this, I am reaching the base level fact table, right? And I know for sure that my query, because my query is always a base level SQL, right, which targets the base level fact table, will ultimately be answered by using this table, right? And it's associated, of course, it's associated dimension tables, right? You can draw this here. So what do you see from this, right? Okay, so we see that it's a kind of a multi-level. I can see an analogy here with what is called as a multi-level caching, right? You understand caching? Multi-level caching. I hope all of you know this, right? So what I do is, so these are my different levels of cache, and this is my final thing that I'm looking for, right? So if I can get it here, my query gets answered very, very quickly. If not, if I am able to answer the query using this one, then again this is quite good, right? If I am able to answer this one, then again I am doing quite okay, right? So the earlier I'm able to answer my query, right, the more speed up you will get in terms of your query response times, right? So if I go here, right, if I have to answer my query using the base level data, then I am unnecessarily wasting time on these, right, on the aggregates all through the way, right? So it's like a multi-level caching. So it's about a miss and a hit. So you know about everything about caching. So if I find it in the cache, it takes less time, very less time. But if I don't find it, if it's a miss, right, then it takes longer, as compared to if I directly went to the memory, right? So that's what it is. So this is multi-level caching. So this aggregate navigation algorithm works just like that. Okay, so the design requirements, so let me clear this. Okay, so now we have the final design requirements for aggregates. So there are 4 rules basically. So aggregates must be stored in their own fact tables, separate from the base level data. So this is the first thing. So this is very important. I'm going to highlight this in the coming lectures, maybe in today's lecture itself. In addition, each distinct level aggregate must occupy its own unique fact table. So what I'll try to picturize this for you. So this is a fact table, which is a base level fact table, and there are some associated dimensions. Okay, so now suppose this is the grocery store sales data, sales fact table, and the dimensions are product, location, that is store, then time, and promotion. Right now, suppose I want to create. So there are a lot of queries on months and categories. Say in this particular month, how much of a particular category I sold. So it's a month-wise, category-wise report that I have to generate. Oh, this is my query. So what I'll do is I'll aggregate this with respect to. I'll aggregate this fact table with respect to what you say with respect to month and category. So this will be a two-way aggregate. Okay, so it will be two-way aggregate. So what I'll do is I'll get is a smaller fact table, and if I look at time, so it will not talk about day. So this is at the daily granularity, as we had discussed in the first case study. This is at the daily granularity. So I'll do the month granularity. So time would now from day, so this was day, so this would now go to month. Now there are lots of attributes in this time dimension here which apply at the day level but do not apply at the month level. Say if I want to find out which day of the week it is, but if I am at the month level, day of the week does not apply, right? So many of the attributes of this table, this dimension table would not apply. So only those attributes would be here which apply at a month level, right? So this would be which we call as the aggregated or shrunken dimension. So I'll be talking about this in the coming lectures. So this will be an aggregated dimension. Similarly, if I go to product, right, product dimension, so this would now become the category dimension, right? So product was here in the original one, so it will now become the category dimension, and only those attributes which apply at the category or level or above will only be kept in this, right, and rest of the dimensions will remain as it is. So this is a, so what I do is I create a additional fact table, right? So this is a fact table, say, which is at the daily grain, and this is a fact table which I have which is at the monthly grain. Okay, so the keys in this fact table would be, so keys in this fact table would be like day key and product key. I'm only using those which are used in the aggregate, and in this it would be like month key, and it will be category key, and this product dimension would change, and also the time dimension would change. So the everything changes. So this is how I store my aggregates. So every aggregate is stored in its separate fact table. So this is what is explained in point number 1. So this point in its unique fact table and associated, of course, associated dimension tables, right? So what I have when I create these aggregates, so I create a family of schemas, a family of star schemas, right? On top you have the let me see if I can show. So let me show you something. So I'll use different colors to show. So I'll use, so this is my base level fact table, say sales, and it is at the daily granularity, and I have, I'll write slightly bigger, I'll use only 3 dimensions, so that, so this is product, and this is time, and this is, I have a store. Okay, so you know what keys would be there in this. There would be a product key, there will be a store key, and there will be a day key. Now when I create, suppose I create a monthly snapshot, and also instead of product I talk about category. So what happens now? So I create, so this is another dimension which is you can visualize it as it is behind this dimension table. So this would be my category dimension. Okay. Similarly, in case of time, it is day. So now I am creating another one which is at a month level, and I am making it making them smaller because because they would be smaller, because some of the attributes which do not apply at the category level but apply at the product level would be removed from here. Similarly, what the attributes that apply at the day level would be removed from here. So these will be shrunken versions of the dimensions, right? And similarly here, what would happen? So I would get a smaller, hopefully, if sparsity failure does not come into picture. So I will get a smaller fact table, right, which will be at the monthly granularity. So now this blue fact table, which is an aggregated fact table, will now talk to the category dimension, and it will talk to the month dimension, and at the same time it will continue talking to the store dimension, because I am not doing any aggregate with respect to the store dimension. So what I have, I had this original green schema which is the base level schema, and then I have created another schema, right, which is an aggregated schema where I have an aggregate with respect to month and category, two-way aggregate. So this is a two-way aggregate that I have created, and it talks to the shrunken version of the product dimension, also to the shrunken version of the time dimension, right? But it talks to the full-fledged store dimension. So these blue dimensions are called as shrunken dimensions, or we also call them aggregated dimensions. Okay, so this is how it looks like. So I have another schema behind this. Similarly, if I create another aggregate, another two-way aggregate, so there will be another schema, right? And these dimensions that are applying, right, so they are not actually new dimensions that we are creating, right? So these are, so the product and category dimensions are actually called as, they are not separate dimensions, they are called as conformed dimensions. So what are conformed dimensions? So if I take any dimension, say for example product, so if I make an exact copy of that, so that is also a conformed dimension. If I remove certain attributes from here, like we did in this case, from product, moving from product to category, then again it is a conformed dimension. Or if I remove certain records from it, then also it is a conformed dimension. So conformed dimensions can be there in three ways. So exact replica. So in the next class I'm going to talk about all these in detail, right? Exact replica, subset of attributes which applied here in this case, and third is subset of records. Okay, so I hope this is clear now. So we get what is called as a family of aggregated schemas, right? So let me just go back to the laptop. Yeah, and let me clear this annotation. Okay. So the dimension table, so this is what I was trying to explain to you. The dimension table attached to the aggregate fact tables must, wherever possible, be shrunken versions of the dimension tables associated with the base fact table, and this is where the concept of conformed dimensions come into picture. So when we talk about advanced dimensional modeling, right, so then we'll be discussing it in much more detail. Okay. Third design requirement, the base fact table and all its related aggregated fact tables must be associated together as a family of schemas. This is what I explained to you just now, so that the aggregate navigator knows which tables are related to one another, right? So this helps basically the aggregate navigator, and force all SQL created by any end user or application to refer exclusively to the base fact table and its associated full size dimension tables, right? So that is another design requirement. So we should not expose the aggregates to the end users for them to use them directly in their code or application, right? So it is mandatory that all end user applications and queries target the base level data, right? So that is very, very important, because tomorrow when I change the set of aggregates that I have, nobody is affected. Storing aggregates, so as I told you, I discussed this already with you, that it is a new fact table and dimension table approach. So this is what I discussed already. New level field approach, this is not discussed, or this is not used at all. So basically what we do here is that we kind of in the same fact table we attach a level, right? And that creates a lot of problems. And so both actually require the same amount of space, but still we recommend approach 1, and reasons are obvious, because it makes things easier for you, right? So you can see what all aggregates are available, and the chances of double counting a particular record is not there, right? So these are the reasons. So this is what we know about aggregates. So today we basically looked at aggregates and aggregate navigation. So the main idea is that the user need not worry about what aggregates exist in the system. So they will just target the base level data, and the aggregate navigator will take care of the rest. So in the next class, so aggregate is a big topic, so I'm trying to break it up into smaller modules. So in the next class I'm going to talk about a couple of more things about aggregates. So let me just mention them to you so that you know what is to be expected. So I'm going to talk about this aggregate navigation I've talked about. So I'll be talking about shrunken dimensions. Okay, so that's one thing I'm going to discuss in the next lecture. Then shrunken and also there is called as something called as lost dimensions, right? So these two things I'm going to discuss in the next class, and plus I may take some examples of queries and show you exactly how these queries are intercepted by the aggregate navigator and are made aggregate aware. And I'll also be talking about how we can do aggregate navigation without or with minimum use of metadata. Okay, so that also I'll mention in the next class, in the next lecture. And I strongly recommend that you read articles of Kimball on the topic of aggregates. So there are 2-3 articles. Which you should refer. Okay, so with this I end today's lecture on aggregate navigation. In the next class, some more aspects of aggregates will be discussed. Thank you.